Good evening. Hopefully, I am audible to everyone. Um, if not, then you'll let me know. Tonight, I'm feeling a bit flustered. Been quite busy all evening, so let me just take a sip of tea. So, I'm picking up where I left off from the last stream, modeling the structure between the table leg of my big crazy wooden reclaimed table leg, but I'm 3D printing the top to it. And last session we modeled the structure that was going to kind of bridge between this top surface and the tabletop. And now I'm going to pick that up, develop the branching structure that I started, as well as maybe think about, if I've got some time, think about how it's going to interface with the wood. Think about how it's going to be mounted on there. Let's take a look at the print. Working much better than the last print. This is because the filament I'm using here is one where I didn't mess up the reel. The last filament kept jamming because when I transferred it from the refill onto the spool, I undid the straps too early and it started to unwind and it lost all the tension. So I got it back on there, but it's causing jams now. This stuff is my matte black filament and it's just great. What I'm testing here is just a plate, but what I'm testing is a wood texture. I found on Maker World a really cool kind of experiment of a wood grain texture that's been cut into the model, which then comes out in the print. So I want to see how that looks as perhaps as a texture that I could use and adapt in the future, and as a method for creating that kind of wood grain in the print. So that's what I'm testing there. If it comes out well, I might show it on next week's print. But if we jump back into the model now, refamiliarize ourselves. So I've got this grasshopper code here with the multi-pipe, and I'm increasing the node size. So the nodes are each of these little corners, and the node size is basically like how big is the sort of ball at this joint. And I can increase the size and it all gets thicker and blobbier. But what I want to do is have thicker nodes and struts at the bottom, and then they get thinner and thinner and thinner as they go up. That's my goal. So I need to try and find a codified, kind of systematized way of doing that. And to be honest, I don't know how I'm going to do it off the bat. So this is going to be a really experimental one, probably with lots of, how does that work? Where am I getting those numbers from? So let's get into it. What I need is to enter a list of values into the node size input there, not just one value from this. And I need a list of points that correspond to those values. Now, I don't actually know how this function interprets all the points. Because we've just got all these curves, which are just lines that intersect with each other. And I'm able to pull out from those curves all the end points. So all the green points are the start and end points of these curves. They're actually lines, but they're called curves in the program. And this gives me this could give me just a list. There you go, that's a list of points. Lovely. But I don't know how this is interpreting those points. So 48 curves. If we start with the start points, because all of these lines are going from bottom upwards. So if we start with all the start points, and see where that takes us. There's 48 of those. Okay, I'm gonna list list items. So this allows me to pull a specific item from a data set. There's my list and index. So 0. This is just helping me see which points are which. 0, 1, 0, 1, 0, 1. Oh. 0, 1, 2, 3. 4. 5, 6. 1, 2, 3. That's really annoying. So that is the start point of 3 different struts, and there's 3 points all sat in exactly the same position. And then I move to the next point, it moves up. And we're not even in high order. These aren't even organized that way. This could be a tricky one tonight. Let's just try and do any multiple values of this node size. See if that does anything. So if we have 1 and a value of 2, and we just stick to that for now. This needs to be multi-line data. Stick that in node size. Okay, it breaks down. Disconnect. They all look like they have a size of 1. Okay, what if I have 1 and then 10? Can't see a single node that's like 10 times bigger than the rest. So that has. If you're supplying multiple radii for node size, these points identify which node to set as which radius. If only some of the nodes have their radius this way, the values will be interpolated across the shape. So if I stick. I don't know if you can see that readout, but when I hold my cursor over this option, a little window pops up giving me a descriptor. Should try and set up my stream so you can see that too, if you can't. Do another panel for 0 and 1. That should be the first item and the second item. Put that into size points. 20. Ah, no, we're trying to get. Okay, yeah, we're trying to get points, aren't we? They're into there, but points into there. Oi, there we go. That's made some kind of difference. Let's not do 10 because that's looking like the elephant. So if I just have one value, that's just the first point. And I say that that has 10. literally just found some point and positioned it in the right place. Okay. Okay. So let's do this another way then. Let's take all the points. That's just all the points. Let's call duplicates. This is going to try and delete any points that are in the same position. And I can set a tolerance. The tolerance is 0.1, so that's fine. 34 locally defined value. Great. So that's my new updated list of points. Hide that. Hide that. These are the points. Great. Now, intersection. What I'm going to try and do is, instead of using data flows to try and filter out the points from here, I get the impression that this function is smart enough to identify, just when it says side points, just if there's a point in that same location by a certain tolerance, it knows that it's the right point. So I don't actually need to kind of filter it in from the source of points. What I can do is basically find the points again. If that makes sense. If it doesn't, don't worry about it. It will as I work through it. But what I'm going to try and do is take my cleaned up list of points and then find which ones are on the planes that I want, one at a time, and organize it that way. So there's ways of identifying whether there are points on a plane or not. Point in curve. Is that doing it for me? No, that's not going to do it because we've got points outside of the curve of that layer. I want to know if the point is on a plane. Okay, got it. We can deconstruct the point. So panel, if I look at the Z value, so what deconstruct is doing is it's pulling apart the X, Y, and Z coordinates of each point. So if I look at these values, I can see some of them will be the same. In fact, there will only be 3 groups because there's 3 tiers of points so far. So I can go into set and I can say find most similar set. Creates the valid set from a list of items. Those are the 3 distinct values. And this is the pattern for passing out the values. Then what we can do is use pick and choose from a set of input data. What is this? Input stream too short for the pattern. $33, so that's 34. 34 points. So that's, what are you talking about? Basically, what I'm trying to do here, this function is giving me pattern. This is telling me which points in this list belong to which of these 3 layers. And it's, layer 1, layer 2, layer 3. It's labeled 0, 1, 2, but it actually means 1, 2, 3. Whole pattern, no. Dispatch the items in a list into 2 targets. Basically, I want to do that, but I want to have more than one output. I want to have 3 outputs. True, false. Not true, false. It's 1, 2, 3. Key value search. Resulting item a list in the value list that matches the search key. No. This is probably the most boring stream I've done so far. But we will get there. Let's check on the print for a bit of mid-time entertainment. Coming along fine? That's good. Sift elements in a list using a repeating index pattern. No. Combine non-null items out of several inputs. No. Cross-reference data from multiple lists. No. Weave a set of input data using a common pattern. No. Oh, maybe. No. Find the occurrences of a specific set. Set to operate. If I take the set of the Z values and the members to search are those three values, then if I graph those, meaning they each get their own layer, and then we check what the output of that is. Number of occurrences. Indices of member. Oh my giddy aunt, here we go. So now we've got three lists representing our three tiers, all the points in those lists. Excellent. So we can now list item, take all our points, use this pattern, then what do we want to do? I want to graft a data tree by adding an extra branch to every item. No, match tree. Match one data tree with another. what I now want to do, I've got my points in groups of which layer they're in. Great. I now want to try and input the node sizes with the same structure as this, so it corresponds. Let's start by tidying up what we've got here. This is turning into a mess. Let's tidy all this up. Okay, that's looking a bit better. Get rid of that. Move that forward. Get rid of that. And get rid of that. Fine. Let's also get rid of the original point clouds. Well, not get rid of, I'm just hiding them so they're not getting confusing on the screen. There we go. The only points we can see are the points we're actually using, which are these points. So I want to try and if I take list length, put that in. What output do I get? Okay, that tells me the quantities in each list. That's good. So I kind of want something like a slider for node size tier 1. Node size tier 2. And node size tier 3. Right, and I want perhaps the lower tier to be thicker, and then it gets thinner and thinner as we go up. And I can adjust it this way. Actually, let's order these so it kind of looks, so it maps a bit more intuitively. And then I want these values multiplied by these quantities. So I want to see, it says 4 in the first list. So I wanted to say 2, 2, 2, 2, and then 10 there. So the next value, I want there to be 5. I want there to be 10 5s. And I wanted to figure this out. So is there like a quantity? That would be too simple. Create a series of numbers. Maybe that's what I want. First number in the series, step, count. No, that's not what. Create a set. No. Stream gate redirects the stream into specific outputs. Construct a data tree branch path. Branch path indices. What if I just put those in? What do I get? No, that's not. I don't think. Oh, this must be. I can do multiply. There's a multiplication here, but that's not what we're trying to do here. That's just gonna literally multiply the two numbers together. That's not giving me a quantity of items on a list. It's going to be something in this section, the sets function. Duplicate data a predefined number of times. Yes, that's what we want. That's exactly. So, data to duplicate. Tier size number 1. No, number of duplicates. So we're going to do that, then that, then that, specifically in that order. No, I don't trust it. I'm going to go through a panel. I want to see it. That, then that, then that. And I want to... no, I do it even more manually. Graph tree. That, then that, then that. So those are my values. I want to put them in data to duplicate those. Number of duplicates. Those. Retain list order. Yes, I do want to retain list order. Hello, here we go. Now we've got a list of values, and the quantity of those values correspond to the number of points in each tier. And I can change it up. Look at that, it's updating perfectly. Brilliant. Now, we should be able, if I'm not mistaken, I should be able to input this straight into node size, and it's going to break. And then I take all my points as they've been organized here, and I stick them in size points. Oh my god. Is this going to do it? Okay. I think we need to tidy this up a bit, buy ourselves a bit of space. What are you? Need some space. Let's stretch these out. And let's edit the slider. I want decimals. I want a maximum value of maybe like 15 mil. Now we're just editing the parameters of these sliders. The tier 1, let's say that's 4 mil. Tier 2, so that's 2 mil. And tier 3, let's say a little bit over 1. What have we got going on here? 1, 2, 3. Why are there 3 different multi-pipes? What? The output here is 3 multi-pipes. Is that because... Do I need to flatten? Here we go. Here we go. Yes. Now, if I change the tier 1 slider, only the nodes on the bottom get bigger. Yes. Then the tier 2 slider, only the middle nodes. And then the tier 3, only the top nodes. Beautiful. Let's say top nodes have a diameter of 1, middle ones 2, bottom ones 4. And we're doubling up each time. I think we could go even thicker. I think we could do maybe like 10. That's quite thick. Well, maybe 5. Too thick. Too much. 8, 4, 2. That could be the way to go. That could be the way to go. And remember, the way that we've set up this whole thing is that I can come back here and edit all kinds of values. So I can add more points. And I can change the sort of permutation of the points. Randomize them. I can change the size of the area that we're working with. I want to keep it at 300. I can change the height. I was going to add more of these tiers, you see. Okay, let's see if for the last tier we can make these endpoints a little bit more useful. As you can see, some of these nodes are sort of forming bends and some of them are just open-ended with the line coming up at a sort of obscure angle. I think if we can get all the final tier of points, let's say kind of perpendicular going up so that they've got a nice join with the top surface, that would be really good. Firstly though, where was my tween? Tween curves. What if I just did that? That's gonna break it. Fine. What if I did 0.066? Oh, what? No, 0.5 and 1. There we go. That takes us to the top. Interesting that it's not really filling the space. Okay, so the populate 2D is filling. Well, where's my factor? 3. What if I did a factor of 4? Increase the number of nodes. And what if I drop the height? It seems like what I'm trying to do is get it to push further out into these corners. I'm not sure what's driving that. Whether it's just random sort of chance. Okay. Sometimes when I change these permutations, it does branch out in different directions. There, I'm right to the edge, which is good. But I sort of wanted to do that more often. I think it's just random. How well it's distributing. I think I would just need to add more tiers to get it to reach properly. Let's get back to optimizing that some other point. What I want to do is try and add to this set of curves another bunch of points. So third layer nodes and structure. What's this doing? Taking the table. Okay. So if I copy those, bring that down, we're going to first, second, fourth. Thanks, my fourth. And we're going to take so this list is taking from the tween curve. I don't want that. I just want to take the top curve. I want to stick that straight in there. Get rid of those items. Actually, that's not what I want to do at all. this isn't well. So what? Delete those. Curve closest. I want to move those points by z vector. And I want the distance to be the difference from that level to that level. Which for now I'm just gonna manually type it. So we're gonna take the height and we're gonna multiply its third, stick that there, and hopefully that should be exactly. We can check. Nope, slightly off. Because it's meant to be 3 recurring. So we find the midpoint of that. That's our top point. We find the midpoint of the plane with all our points on, which is going to be there. We deconstruct these points. There. I'm sure there's a better way of doing this, but this is very manual. Doing this. Subtract the z value of the higher point. Yeah, we subtract the difference. That should then give us a value for the height difference. Put in there. Check that now. Yeah, bang on. Perfect. And now you view those off. So here is simply just moving those points from the layer below directly up, so that these lines, if we just do a line straight from that list to that list, 64. We actually just want to flatten and now those are just lines that go straight up, and hopefully if I stick that in there, it kind of works. Kind of. The thicknesses, I'll need to update the thicknesses. That will be for another night. What I can do real quick is instead of it being at thirds, I could say the first tier is halfway up and the second tier is like 90% of the way up. There we go. There we go. Kind of interesting. This is coming along. And it's working every time. Oh, brilliant. We're going to get somewhere. We're going to get somewhere with this. All right. I think it's time I love you and leave you. It's been an hour. Apologies if you've been tuning into this and realized it's probably one of the most boring streams I've done so far, but this is exactly the point of my process. The reason why I'm streaming is to just put out there in the raw both the fun stuff and the just grind stuff. And this has been a problem-solving grind kind of evening. But on a cheerier note, the print's looking okay. So I'll look forward to taking that off the printer later this evening. And I'll catch you next week.